Our next presenter is Cibele Hummel to Amaral, and she is from the University of São Paulo in Brazil.
Good afternoon, welcome to my presentation. My name is Cibele Hummel do Amaral. I'm a PhD student in the University of São Paulo, and I will present to you the work entitled Change Analysis of the Spectral Characteristics of rubber trees at canopy and leaf scales during the Brazilian autumn. Belong to the Euphorbiaceae family, the genus Hevea, with natural distribution in northern of South America, mostly in Brazil, has 11 species, being the main historical and commercial representative, the Hevea brasiliensis species. To establish resistance to pests in plantations, more productivity, and adaptability to different climatic conditions, genetic improvement was inevitable for the success of plantations. Nowadays, the major producing region is Southeast Asia. There are some remote sensing papers about rubber trees. However, approaches about canopy chemistry in hyperspectral analysis of this important forestry were not found in the literature. The aim of this research was to verify the potential remote detection of the changes suffered by rubber tree clones in the late autumn from May to June, with the drop of average rainfall, average temperature, and photo period. Indirectly, we also analyzed the ability to discriminate in the clones and to help the understand of the behavior of these clones at two dates in autumn. The research was developed using multitemporal hyperspectral images from prospective airborne sensor and multitemporal ultraspectral spectrometer instruments from AST field spectrum resolution. The study area is located in the experimental farm of the University of Campinas in Paulínia City and comprising around 2,000 square meters. The plantation was established in 1988 with 2 stands of PB235 clone, and in the middle the clone GT1. Each stand have 40 plants. The genetic variations between the clones, the PB235 is a secondary Malayan clone, and the adult trees reveal homogeneous branch formation, and the leaves are green with intense coloring. The GT1 clone is a primary clone developed in Indonesia. The canopy opening is very late and it has a variable habit. The leaves are dark green and bright. The authors considered the terrain characteristics homogeneous, considering the characteristics of the literature. So, the main environment variation was considered the sunlight and shading, mainly in sunrise and in sunset. It's possible to see that the clone PB disposed in the west received more sunlight, mainly in the afternoon, and the PB clone in the east have adjacent tree taller and bigger. They used equipment to develop the research were prospective airborne sensor and ASD field spectrum high resolution spectrometer. The dates of data obtaining of the first happened in 2010 and the second in 2011. The first to obtain the canop data and the second to obtain the LIVIS data. For the canop data, we generate spectral libraries with the average behavior of each stand for each study dates. For the leaf data, we generated we collected leaves in the canop. After that, we obtained measurements of 5 leaves per tree and the extraction of the average. Resampling for the same number of bands of the prospective sensor. And after that, we generate a spectral libraries with the average behavior of each stand for each study dates. For the comparison between the different data, we used famous literatures like Blackburn, Barrett, Jensen, Kokali, Austin. So the results for the chlorophylls, it's possible to see that the Gtion clone has the highest loss of A and B chlorophylls from May to June. In leaf scale, happens similarity between the stands of same clone. For the carotenes, there were decreases during the period in this spectral region that coincides with the B chlorophyll absorption peak maybe covers the absorption by carotenes, mainly the photoprotectant. For the anthocyanins, an increase of reflectance was observed for all 3 stands, except for the PB northwest stand in canop scale, as you can see at the top. Considering the ratios generated between the stands in canop scale and in the visible region, it's possible to observe that exists a pattern of the stands of the PB clone that differs from the Gtion clone. Opposite patterns in May with increase and decrease is observed too. In leaf scale, this pattern is observed too, around 550. Opposite patterns in June is observed in the region of the peak of absorption of chlorophylls. In the near infrared, genetic aspects were observed, mainly because that the GT1 clone, there is the high-test absorption value. And environment aspects were observed too, mainly because the PB Northwest is more exposure to the sunlight. For the absorption peak of lignin and proteins, we observed that the GT1 presents the highest absorption values of these compounds. Considering the ratios between the stands in canopy scale and in the region, the near infrared, it was observed that the ratio GT1 and PB southeast ratios are closer of 1. That explains environment aspects. In leaf scales too, the same behavior. For the cellulose that measurement obtained only in the leaf scale, considering the peak of radiation absorption by the atmospheric water, it's possible to see that the GT1 clone presents the greatest index of this compound except in male. The low variation of the reflectance values of the PB southeast, the most shaded stand, showed that over the time the light intensity decrease is not able to stimulate the plasticity of thickness reduction of their leaves. For the starch, we don't observe any genetic or environment patterns. The starch can be reserved to be consumed in stressful conditions, however, also depend on the leaf position in the branch and the period of the day. Considering the ratios between the stands in canopy scale in the Surrey region, it's possible to see that in June, with the approach of the winter, both PB stands started to present similar patterns, but different from the GT1. What didn't happen in May. In leaf scale, it's possible to see too that the GT1 and PB southeast were spectrally more similar, indicating difference from the PB northwest in the both dates. In this spectral region, the similar spectral absorption features of leaf compounds may be complex, how said Kokali and some others authors. The conclusions, it was possible to discriminate different Hubbard tree clones using the hyperspectral remote sensing by the comparison of spectral response of two different moments of autumn. The method was considered efficient for the detection of small environment variations and different clones' behavior during the autumn. Both canopy and leaf scale not always present similar results, mainly in the swing. For the visible region, mainly in June, the spectra indicates a genetic similarity regardless of the sun exposure condition. The greatest loss of A and B chlorophylls suffered by GT1 clone is the main point on the clone's distinction. The June measures at near-infrared indicate that environment variations were noticeable and very similar in both scales. as the soil it is enhancing. The influence of the morphological differentiation due to sun exposure intensity and the quantity of structural compounds. The rates analysis indicate that in general, in the visible region, predominate genetic patterns. In the near region, prevalence of environmental response, and in the soil region could be seen more environment aspects may and trace of genetic patterns in June in canopy scale, closing to river. The variability among the results on both leaf and canopy scale may have suffered influences by the fact that the last one comprised leaves with severe levels of sun exposure and non-leaf vegetable material. Thank you so much.
Do we have any questions for Cibele? Yes. Yeah, I'll take the microphone if you want.
Please speak slow.
Hello? Can you hear me?
Yeah.
I just speak loud.
Okay. I have a question that I'd like to know more about the remote sensing aspect of your topic. That how do you do the atmosphere correction to your data?
The
atmosphere correction.
My data of the images. I received the images with the correction of. I just processing. No, I didn't make pre-process.
Okay, that's fine. And when you talk about canopy scale, I noticed that I think if I remember the numbers correctly, you have the pixel resolution of 1 meter,
Yeah.
and you have your rubber tree stands as 3 meter by 7 meter spacing.
Yeah.
So when you say canopy scale, are you averaging everything into one single value?
Yeah, I considering the soil or other things under the canopy, like background, considering the similarities of between the stands,
Okay.
and I consider it like a background.
Okay. So if we were to use the results for operation, then what kind of pixel resolution? But in the result, so it seems you are using a pixel resolution as much as like 30 meter by 30 meter, because it's your plot. Is that much? Do you understand what I'm saying? No.
That's all right. Maybe we can have this discussion afterwards.
Sure.
Okay, thank you.
Thanks,
Sorry
Cibele.
for.
So our next speaker, do we have Mamadou here? Okay, perfect. Okay, so Mamadou Ramu is from Bangladesh Space